right, guys, so our next speaker, I have the pleasure of introducing J. Paul Reed. He goes by Paul. He is the founder of a consultancy called Release Engineering Approaches that helps teams, both small and large, with their DevOps journey, and that can be culture, technology, all aspects. So he's an internationally recognized speaker on DevOps. He's also the author of DevOps in Practice. I've actually had the pleasure of hearing him speak. He is a super awesome, cool speaker, so not to hype you up, but so I'm really excited for this one. Thanks, guys.
All right, how are we doing this morning? So I'm going to start actually with a survey, although kind of stole my survey thunder, so we know there's mostly developers in here, which is cool. But I want you to keep your hands up as I ask you these questions. So how many people in here are responsible for running postmortems or retrospectives? Like they run them. Okay, now how many people, keep hands up, how many people attend them? Retrospective postmortems. Okay, and then how many people, when the site goes down, want to read the retrospective and go, what in the world happened? Want to figure out what's going on? All right, number of hands, right? So that's what we're going to be talking a lot about today. And the other thing I wanted to ask is, how many people have heard, hey, we're doing this DevOps thing, so we need to learn to experiment and fail fast, and that should be okay, and how many people have heard that rah-rah speech? Yeah, okay. It's pretty common in DevOps. So I want to actually start today with a thought experiment. And this is based on a talk that I gave a number of years ago called Is Your Team Instrument Rated? And there's a link at the bottom that kind of got cut off, but I'll post these slides. And it basically asks the question, if we look at other operational endeavors that humans are involved with, and then we apply that to DevOps, what could we learn? And so the one that I picked was aviation. So if we think of developers as pilots, and operations engineers as air traffic controllers, what could we learn from that field that might be applicable to our day-to-day life as developers and operations? So that's that talk. But I want to do sort of a thought experiment in what I call the JFK data center. So this is a real clip from JFK Airport. And I'm going to tell you right now, I'm going to ask you questions later about what we're about to hear.
American 2 Heavy, ILS 22 left approach.
American 2 Heavy, Kennedy Tower, runway 22 left, you're number 2 for the field. Traffic's on a 4-mile final of 31 right. Wind is 320 at 22, clear to land, runway 22 left.
22 left, American 2 Heavy. Heavy visual for 22 left.
American 2 Heavy, 22 left, you're clear to land.
Clear to land. 22 left. Your localizer is not firing.
Okay, I will double check it. American 2 Heavy, I just reset it. Should be coming back up in a little while. Wind now 32023, gusting to 35.
American 22, we can't land on 22. We're breaking off approach, and if you don't give us to runway 31 right, we're going to declare emergency.
All right, I'll pass it along. Fly runway heading for now.
Okay, we declare emergency. We're going out 31 right. We're going to the left, and then we're coming around.
American 2 Heavy, just fly runway heading.
The area.
Okay, you're saying you're declaring an emergency at this?
3 times I've told you that. 3 times we're declaring an emergency.
Okay, I just want to verify. I know you told me if you didn't get 31 right, you would have to declare emergency. Okay, I understand. Fly runway heading, and I got to get you a turn.
No, we can't.
JetBlue 62, the left on Alpha and monitor ground to the ramp.
That's Alpha, I'm on the ground. JetBlue 62.
I head in 180.
You don't American 2 Heavy. We are turning around to the left here and landing on 3-1. Remove everybody from our way. We've declared an emergency.
So that doesn't inspire a ton of confidence, does it? But I have a question for you, right? So was this event a success or a failure? And I want you to think about that and decide in your mind, was this a success or a failure? Who in here is going, I want to know if they landed? Right, okay, yeah. We're going to talk about that. So come to think of it, like, what is success? Is it just the absence of failure, or is it something else? So that's kind of what we're going to be talking about today. So this is me. I'm not going to go through this slide. This slide is actually really about Twitter, and I know like this is the only event happening in Washington, D.C. today that people are talking about on Twitter, so feel free to tweet about it. Or tweet questions at me or what have you. The other thing I actually will point out is I'm a Master of Science candidate in Human Factors and System Safety. And the reason I point that out is because we're going to be talking a lot about the safety sciences and human factors. And so a lot of the stuff that we're going to be talking about comes from that. that body of work. The other thing that I would point out is a lot of this has to do, and I want you to think about this as we explore some of these ideas, about your own feelings about failure, right? If you were raised where, you got knocked off the horse and your parents were like, hey, get right back up on the horse, you might react to failure differently than if they said, hey, maybe you should be playing the clarinet. And so we need to think about our own sort of conceptions of success and failure, specifically failure. And also there's a big organizational impact that we need to think about. So be sure to factor those into kind of your thoughts about this topic as we go through them. So what's interesting is you actually see a lot of organizations doing really interesting things in this sort of post-mortem failure space. So this is I just did a Google search for Chef postmortems. Chef does their postmortems in public on a Google Hangout. And if you think about that for a second, it's like, what would you think if you had your postmortems like live streamed? What would that be like, right? But they do this, and they let anybody attend and join, so that's kind of interesting. Have anyone heard this term blameless postmortem? Does it seem kind of weird? Yeah, some kind of weird. People are like, okay, how can we have a postmortem if we don't blame someone? I actually stole this slide from Jason Hand. He lives in Colorado, and I'm based in San Francisco. So a lot of times people are like, what are you guys smoking when you hear this blameless stuff? But yeah, so we're going to talk a little bit about that. And then also, it's kind of funny. There's this, sort of, craze in Silicon Valley. We hear about this a lot. This kind of like failure fetish, it's called, people refer to that, I love this photo of this developer. It's like plaintiff developer looking plaintiff, right? He's probably, complaining about his $5,000 a month SF rent for like half a bedroom or something. And I know here in Washington, D.C., like when you hear what Silicon Valley is doing, sometimes you kind of have this reaction to it. Because I remember going to one of the first or second DevOps days, D.C., and it was really interesting to me because the federal government space has to deal with lots of problems that Silicon Valley is like, we'll just write an app for that, right? So I totally understand that sort of context as well. So let's start with this idea of failure as success and sort of what that means in terms of a mindset. Now, we're going to be talking about these words a lot today. And, retrospective, accident, blame. And really, in some sense, we're talking about this concept of safety. And you might say to yourself, well, okay, what does safety have to do with, a website where we're processing permits for things or something like that? Is anyone familiar with Knight Capital? Anyone heard of the Knight Capital case? See a couple hands going up. Well, Knight Capital was a high-frequency trading firm. And this happened in August of 2012. And what they did is they basically did a deployment on a Wednesday. They opened up for trading on a Thursday, 9 a.m., started doing trades, halted trades about 9:45 a.m. because it turns out that something, they weren't sure what it was at the time, something was causing them to basically lose $170,000 a second for 45 minutes. So they ultimately lost $460 million. And that was Thursday. On Friday, they're literally out of business, right? So that's one of the things in the systems that we often build and the incidents that we encounter. We can actually have a situation where we do a deployment on a Wednesday, and Friday we could be out of business, right? So it's kind of interesting to think about it in that context. Now, you might say, hey, we're not doing high-frequency trading, so that's kind of weird. Maybe that's not a problem I have to think about. Well, I would point you to this, which is kind of funny. This was recently this year. It was the PetNet feeder. So it's this idea you could buy this little feeder and you have a little app on your phone and it can like feed Fluffy and Fifi back at your house at scheduled feedings or whatever. Now what's interesting about this, they say at the bottom, we're experiencing some minor difficulties with a third-party server. I assume they mean this cloud thing that everybody's talking about. And because of that, they couldn't operate people's feeders. They were starving people's pets. Right? So it's interesting to think, it's not clear that they ever said what that third-party server was or what it was doing. But as we get into a more connected, complex world, some of these connections aren't really evident that something we do could have vast implications to somebody downstream from us. All right, so I want to start talking about this idea of safety and sort of how we thought about safety for a really long time. And our initial ideas of this concept of safety come from safety and failures. Failure is sort of a release of energy, an uncontrolled release of energy, right? And a lot of these ideas come from the post-World War II era where we had a factory floor, and we could look at the stations in the factory floor and see products moving from place A to place B. It was very visual. We could actually kind of map the system and play, right? So we also had this model that since it's linear, we can sort of design safety in. We can engineer safety into our systems, and that should be possible and should be actually easy, right? But so then the question is, well, all right, if you want more safety, what do? Right? You add more barriers. So this idea of defense in depth, right? And so that's that idea like with a nuclear power plant, we build bigger concrete barriers. Or, you know, this is one of those machines that lays concrete barriers alongside a highway, right? So we'll just spread the highways, the lanes out and add more barriers. And that's going to keep us safer. But then something happened that in the late 70s, early 80s, that turned this entire idea on its head. Does anyone know what that is? Any guess? This happened. 3 Mile Island. And what's interesting about it is one of the major sort of takeaways from 3 Mile Island is that we're dealing with sort of a complexity on a scale that we haven't dealt with before because we scaled those things up. Now, if you know anything about nuclear power in the United States, basically nuclear reactors, the first sort of generation of them that we built, are basically nuclear submarine reactors that we made way bigger, and then we bolted a generator onto it, right? So we scaled these systems, and there's some complexity that we didn't really expect in that. The other problem is we don't have direct observability of this system. We can't go into the core and take the temperature or look how much water is there or look at the pressure. We can't do that ourselves because we would die. So we've got monitoring to do that for us. Does this sound familiar? In systems of scale, we actually can't look at all of them. We have to trust our monitoring, which is, of course, why that's so important. There's a kind of a really funny story about TMI. You remember those old line printers? In fact, probably some of them are still in operation here in DC and places, right? That print out and they have the line paper, right? And they, the dot matrix things, right? They had one of those in the control room, and it would print out as a record of events that happened, right? And when 3 Mile Island happened, it started printing stuff out. And after 8 hours, they turned the printer off because after 8 hours, it had only gotten through the first 4 minutes of the event. That's how quickly these things can happen. Again, back to that Knight Capital example, right? And our systems are just like this. So there's a sociologist that came along, his name's Charles Perrow, and he said, oh, okay, well, this linear model that we have for the world clearly is not working. So he came up with a model where there's two axes, right? There's the degree of linearity or complexity. So in other words, how linear or how complex our system or our process is, right? And then the other model was the degree of coupling. So that's the components of our system, how tightly coupled are they together? Can they sort of withstand perturbations and not propagate that through the entire system? And his thesis was certain systems, the complex and tightly coupled ones, will have accidents. And he also said, this is normal. In fact, it's called normal accident theory. This is normal, and also it's unavoidable. There's nothing you can do about it, right? So this is from his book, and it's kind of an interesting graph, right? You've got loose coupling down here, and then tight coupling at the top, and then linear to complex. I think it's interesting, you might, a couple of the points on this graph, up near tight and linear coupled are dams, right? And I live in California, so if you remember the Oroville dam crisis, suddenly we start caring a lot about tightly linear coupled systems, right? Because dams are pretty linear. They're not hard to understand. But if you start losing bricks in a dam, it's pretty tightly coupled, and you're going to lose the dam, right? Down here, he's got some funny ones on up here. Loosely coupled and linear, so our single goal agencies like the DMV is on here. He modeled that, which is kind of interesting. Over here in more complex but also loosely coupled, he lists military adventures, which is kind of an interesting one. But really, so what he was talking about is complex, tightly coupled on the upper right-hand side, nuclear power plants, and then also next to it is nuclear weapons accidents. Kind of an interesting thing to think about. Now, one thing that you should think to yourself is, where would I put our organization or our application on this graph, right? So a group, so this was kind of how we thought about safety for a long time. And a group at Berkeley realized, hey, there's a lot of organizations that aren't having accidents at the rate that we would think we should see them. They're tightly coupled, they're complex, and yet we're not seeing them. So they studied nuclear power, they studied the power grid. The coolest one I think they studied was the deck of aircraft carriers. And so what they found, and they called these high reliability organizations, what they found in HROs is kind of fascinating. They found that these groups emphasize constant active learning. So it's a lot of like on the job, you're actively learning things, and they value that over the course of your entire job or career there, not just, they don't just train you and say go forth and do the thing, right? They're constantly doing this. One of the ways they actually do this is crew rotation, right? So they will rotate people out every 6 weeks to a different position or different role. What's interesting about this is there's actually, when they did a bunch of interviews, one of the people on the deck of the carrier said, yeah, I feel like as soon as I know what my job is, I'm on to the next thing. But that keeps them fresh. Now, the other thing they found is that decentralized active review of what was going on the deck of the ship. Now, if you think about that, those two first bullet points are required to make this work. Because if I'm supposed to check whatever you're doing on the deck of the aircraft carrier, but I don't know what you do, then I can't check your work, can I? Right? So they realized if we're going to have this sort of cross-check that happens, it's not an active thing where I say, did you do the thing, did you do the thing? It's just I'm paying attention to see if things look right. I don't know what right looks like unless we do this the crew rotation and the active learning, right? Rank is de-emphasized, I think oddly, or this was a surprise, right? And this is the idea that the lowest ranked person on the deck of the carrier can say, hey, we need to stop the airplanes coming in because we've got a problem. And they would do that and then figure out what was wrong or why the person said that. So it wasn't a big contentious conversation. So I thought that was an interesting finding. And finally, probably the most interesting one is success may be failure. So this is the idea that the plane lands, goes to its parking spot, the pilot gets out, yay, hey, how's it going, right? And basically everyone on the deck of the carrier is like, that was horrible. That was a total failure. Now, if you step back and looked at it, didn't bend the airplane, didn't bend the pilot, right? Didn't bend the ship, everything's fine, right? But everyone in that system said, no. This was way too close to the edge for us. We consider that a failure. And they would treat it as such, even though there's no external sign that there was a failure, right? Okay, so let's summarize what we've been talking about. We have this idea of energy and barriers, normal accidents, and high HROs, high reliability orgs, right? So the shift that we see is sort of static processes and repeated defenses. That's how we solve this problem, to sort of more active defenses and processes, right, that are fluid, can change. There's some variability in them, and that's actually okay. We want that. We also see this idea of technical and engineering solutions moving from that to solutions inherent to the people and the way that the organization does their work. Right? What's important here is the way that the organization thinks about how it does work is critical to this idea of continued safety, as it were. Now you might ask yourself, okay, what does this have to do with technology? How do we apply this shift in thinking to technology? Well, we can look at sort of what we see trend-wise over the last maybe 20 years in technology, right? Who's from an operations or had to deal with like backups and redundancy and DR sites, disaster recovery sites, right? That was the big thing. Like we'll have something off-site and we'll switch to it, and that's totally going to work fine, right? When we try to do it. That was the way we solved this problem, right? And you see a shift to simplifying our systems, decomposing them, right? Microservices is an example of this. By the way, did anyone here have to ever program COM or Corba, right? COM and Corba are the same idea, right? We'll take this component, we'll make this component really good, we'll test it, and then we can reuse it, right? So we can decompose our systems that way. And finally, what you see now is drilled incident response, retrospectives, red teaming, and value streams. So thinking about the value streams. Are people familiar with the term red teaming? Yes? No? Red teaming is where you hire someone to like hack you and pay them to hack you and then tell you how they did it. And there are companies now that actually have a team that does this. It's not a one-time thing. Like every Monday they go hack foo.com. And it's an interesting exercise, especially the first time it happens. All right, so the methods. How do we actually do this? We talked about the mindset. Let's talk a little bit about the methods. Injecting failure. So I'm not going to talk about this because a bunch of people have talked about this today. The one thing that so this is obviously Netflix's Simian Army, but one thing I will point out, I was doing this presentation at a large corporation, and they were like, yeah, we've heard of this. And so we were just talking about it, and they didn't realize they do this in production. They thought Chaos Monkey was running around their dev environments turning things off. And I was like, no, they do this in production, right? So that was sort of an epiphany for them. But you don't need just like a Chaos Monkey tool to do this. You can do this yourself, right? So a lot of organizations out in the Valley, a lot of companies are doing things like, I want your laptop, I want your VPN key fob, I want your cell phone, give them all to me on a Thursday, go home. You get Thursday and Friday off. Then we're going to drill an incident response, because then we're going to find out everything that he knows that the rest of us don't know, right? That we have to figure out. It's also very popular because you get a 4-day weekend if you get picked. The other thing that people we are seeing are hardware chaos monkeys, and that's where you go to someone and you say, give me your laptop. And if you're working on maybe a Windows machine, then I take your laptop and I give you a Mac. And I say, all right, run an incident. And the reason they do that is because if you think about it, we have like all of our SSH keys and our GPG keys and all of our credentials and VPN stuff on that laptop. And if that laptop gets stolen or doesn't work for some reason when we have an incident, then we should at least know, what are we going to have to think about if I give you a new laptop and I need you to run an incident, right? So there's other kind of interesting ways that people are starting to do this failure injection and sort of chaos testing stuff. Incident crews, incident command and crews. So this idea of taking a lot of this research comes out of the fire service. So the idea of like, how do we form a crew to deal with our incident? And then how do we also reset that crew? So there's an interesting thing going on. With the organizations that are doing this, you find that they're getting really good at coming together to put out the fire, right? We have an incident, let's all get together and let's put out the fire. Really good at that. But then they're really bad at the follow-up. And the analogy I give is it's like your house is on fire and the fire department shows up and they put the fire out and that's great. And then literally they take all their gear off, they leave the fire truck parked there and they just walk away. Hoses out all over the lawn, right? But they don't do that, do they? They roll the hoses back up. They drive back to the firehouse. They back into the firehouse instead of going in head first because when they have a call, you want to be able to just go and not back the fire truck out, right? So the point is they think about how to dissolve the crew as importantly as they think about how they form it. And that's actually one of the things that a lot of organizations are struggling with and starting to get better at after they sort of realize how important the storming, forming part is. Postmortems are a thing. I asked about blameless postmortems, right? I sort of asked, like, does that feel, I'll ask again, does that feel weird to anyone, this idea of blameless? I won't blame you if it does, right? The reason for that is blame is actually, we're hardwired for blame. There's a researcher named Brené Brown who does research on this, and she does research on things like vulnerability, and she says blame is a way to discharge pain and discomfort. So what she means by that is we're actually hardwired to get rid of bad feelings by blaming other people. So when you say blameless, it's like we're all ignoring a thing that we all are actually hardwired to do. So it's a subtle point. I wrote a blog post about this. You can go read about like blame aware versus blameless. I think we're stuck with the blameless term, but if it feels weird, that's fine. It's a common reaction. All right, so what should we do when you have an incident? Debrief the actors, right? Get them all together, debrief them. Right? We want to gather the data that we have, so this is why metrics and telemetry are so important. And then what we want to do is create a timeline of the event. And what's interesting about this is that there's good timelines bring all of this information together, right? So they have our metrics data on the top. They have a recording of what tasks were done. So did we do a deployment to solve this problem or create this problem? Did we pull a load balancer out, and that was the problem? Right? And then one of the reasons that you see chat ops being so interesting and talked about is because you have a recording of like what people said and when they did it, right? So if they're talking about things, they can know immediately sort of who said what when and start to correlate the data. And what you'll see in the timeline is these vertical lines, T1, T2, right? Those are called events, capital E events. And you can start to distill information out, critical events that pivoted the incident to a new state, right? And you'll see it up here with, the metrics going up, but there was a task that just finished, and then somebody say, you see it, right? Because this got higher, right? And then these metrics are starting to come down, right? And you can't do that unless you are able to look at as much of that data as possible together to figure out what the pivot points were. So that's why you see this concept of sort of retrospective ready infrastructure, right? And so I mentioned chat ops. Have people heard of chat ops before? Right? The idea that we do all of our work in a chat room, even deployments, right? Teammate is a take on that. It allows you to multiplex terminals. So you can do things like pilot, co-pilot. Like if you're working on an incident, you can both look at the terminal and have somebody like cross-check your work. So that can be useful. And then incident response management tools. Like the current generation of incident response management tools take this into account. So they provide you with the tools to be able to collect all this data. And then some of the tools are starting to actually put it together for you in sort of this coherent timeline dashboard type presentation. Okay, failure success, the landmines. Let's talk a little bit about the landmines. So organizational incompatibility, what do I mean by that? I don't want you to go back to the office tomorrow and be like, hey, I heard this guy named Paul Reed talk, and he said we should just do failure, so I'm going to pull cables out of the wall and see what happens. Don't do that, and don't mention my name if you do. So some organizations have difficulty with this, and it's worth acknowledging, right? There's this great book called The No Asshole Rule by a guy named Robert Sutton. He's actually a professor at Stanford, and he wrote a book, and this book has a bunch of really funny numbers and interesting stories, funny numbers. It's got things like the total cost of asshole, which is apparently $160,000 a year. Good to know. It also talks about how you build organizations that sort of make this sort of behavior unacceptable or frowned upon. By the way, he defines very narrowly what he means by the phrase asshole. But one interesting quote here, the best single question for testing an organization's character is what happens when people make mistakes? All right, another landmine, only certain groups get to fail. So what do I mean by this? Well, if you've ever worked on, development staff, my background's release engineering, and I know that like when operations or release engineering had a failure, it was like you're bad, you've done bad. But when developers write bugs, it's like, well, we just go open a ticket. And so it was always like, wait, what? What? Right? But you see this a lot at certain organizations where it's like certain teams are not allowed to fail, but others are, right? A great example of this, this is from the Toyota production system. It's a Toyota plant. Those arrows are pointing at something called an and-on cord. And the and-on cord is the thing you pull and the line stops. And what happens is a manager comes over and says, hey, you stopped the line. Why did you stop the line and how can I help? And then they and the worker solve the problem or engage more team members to get the problem solved. What's interesting is that GM opened a plant in Fremont, California, which is actually not far from San Francisco. And they built the plant, it was a joint venture with GM and Toyota. And they put the and-on cords in, right? And someone pulled the and-on cord, American worker pulled the and-on cord, and the American manager came over and said, why'd you pull the and-on cord? Why'd you stop the line? What did that manager just teach that employee? And everybody who saw that interaction to never, ever, ever do again. Pull the cord, right? All right, forgetting to dampen failure where possible. So what do I mean by this, right? Well, organizations that do fault injection and team exercises, red teaming, they don't just randomly do it. From what I've seen, if it's an actual exercise, they schedule it, and maybe only the executives know, but they schedule it. Usually most places schedule it, and it's pretty open, everybody knows, right? And in them, like, if you're having a bad incident that you're drilling, like, teams can cry uncle and say, we got to stop the drill, right? Because that's the point, is learning, not just seeing what happens, right? The other thing I would point out about Netflix is that what's interesting is we talk a lot about Chaos Monkey. Chaos Monkey is opt-in, like you can't get out of doing it. But one asterisk to that, you get a grace period when you write a new microservice. Because their thinking on this is, well, if you wrote this microservice and you put it into production, and you're really not sure operationally how it's going to work yet, it would be really bad if we just didn't give you a way to have Chaos Monkey not shoot it in the head and cause problems for you where you have to get up and respond to the incident. So they give you a grace period to figure out how the thing that you wrote works. It's not just, hey, let's Chaos Monkey all day long. One of the other landmines, only reviewing failure. So what do I mean by that? Well, so this kind of looks weird, right? You have this plane coming in. It's kind of, it looks weird at the end, but it worked out. So that's cool. Neato. Right? And then as we do this more often, we might say, well, we'll push the system a little more, right? And we get to this, and it's like, oh, that looked kind of sketchy at the end, but meh, worked out. Then you see something like this, and you'll note that the left wingtip touches the runway, and then is not even on the runway anymore. But he got out of the situation, so okay, maybe that's okay. And then you see this. California, sunny day, bright, and right at the end, that happens. Okay, I doubt any of you want to be on any of those planes, but which one got the postmortem? The last one, right? So that's an example of what we call outcome bias, right? We look at situations that had a bad outcome with much more scrutiny than we might look at other situations that were kind of bad, but hey, we got out of them, so let's do it again. One of the other things that you'll see a lot is this idea of hindsight bias, right? So in other words, that's the bias that if we know the outcome, then we can go back in time, and that's why I kind of have the time machine here, and say like, why did you do that, right? We ask these questions, well, why didn't you notice this? Well, why didn't you not push that code that you knew was bad, right? But we only ask those questions because of hindsight. We can only know that we would want to ask them after the bad thing has happened, right? So that's hindsight bias. Correspondence bias. I'm going to read this, the definition for it. The tendency to place an undue emphasis on internal characteristics to explain someone else's behavior in a given situation rather than considering external factors. This is the quintessential DevOps bias, right? So you've got development, you've got operations. Development, I want change, I want stability, right? And what's interesting is that they're all smiley and happy here, right? And like literally the second they have to talk to each other, frownies, right? Because the developers are like, oh, there's operations people. They want to run everything on CentOS 3, and that makes my life horrible. And then you've got the operations people saying, oh, those developers, they just want change. I hate them all because they're developers. That's correspondence bias, right? So we see that a lot, actually, in sort of the DevOps space. So we are awash in a sea of biases, and this slide is not, I just went to Wikipedia and was like, human bias. And there's like all of these, and you can go read the studies. Most of these have been actually reproduced a number of times, so that's kind of fun. One of my favorite ones on here is the IKEA effect. Do you know what the IKEA effect is? The IKEA effect is we value something that we built more than if we didn't build it, right? So you could have this like crappy IKEA particle board bookshelf, but you love it because you had to look at those weird instructions for 4 hours on a Saturday and like put it together, even though might be this nice mahogany bookshelf. We value that other thing more. The other one, by the way, it's crazy, is the rhyme as reason effect. And that's the bias that when whatever you say happens to rhyme, people will believe it more of the time. They've done studies. And if you think about this, why do political slogans, why are they always rhyming or alliterative? Rhyme as reason effect. So here's the thing, bias is built into the way our brains function.
So what you'll hear is a sentence, a spoken sentence, that's been transformed by a computer to sound like gibberish. Any idea what they said?
No.
You can hear it one more time. Okay, now we'll hear the real sentence.
The Constitution Center is at the next stop.
Does it make sense that time?
Yeah, wait, was that the
It
same?
was the exact same sentence that you heard the first time.
No way.
It's the exact same sentence. Your brain is always using prior information to make sense of new information coming in. So once you know what the sentence is, when you go back and hear the distorted version, you can apply that information and it makes sense.
Isn't that crazy? So the thing I want to point out, it's not like you can get around bias. It's literally too baked into the way that our brains work. The point that I want to make is be aware of it in postmortems and retrospectives. And teams that are really good at it are really good at identifying their own biases and biases of others in a positive way in that sort of group setting. Burr actually talked about this. I'm going to show you a video that it was going around the internet. It was a very amazing video. It was this picture of this huge Range Rover SUV that was stuck in the tundra somewhere in Africa, I think it was. And this man like single-handedly pushes it out of the tundra. It's an amazing video. So let's watch that.
¡Cachi, va ahí! ¡No acelere! ¡Ay, la va a dañar! ¡Espérate, yo te voy a ayudar! ¡Espérate!
So, and Burr mentioned this morning, right? Our context and the lens that we see things through is also going to bias the way we think about these situations, right? All right. Garbage in, garbage out. All this means is if your incident response process is messy, your retrospectives are going to be messy, right? So if you're starting down this journey, I would focus, and your incident response is not particularly crisp, I would focus on that first, and not so much about the learning, because it's going to be hard to learn when everything's chaotic, when the incident's actually happening. All right, deprioritizing retrospective and learning processes, right? So I get that like everybody's busy, and we all have things to do on our calendar. But how many people, when you have a retrospective like this happens? So on Wednesday you have an incident, and it's like an 8-hour incident. You work it, you find the Band-Aid, you put the Band-Aid into production. Okay? You say that was really bad. We're gonna do a retrospective on Friday morning. Friday morning rolls around and that Band-Aid breaks. So you have another incident, that's another 8 hours, and then you're like, we're going to the bar. We're not going to do a retrospective at Friday at 5, right? So we go to the bar. We'll do the retrospective next Tuesday. Well, then it turns out that on Tuesday, an engineer that was involved in the incident is on a week-long vacation, so they're not there. So you're like, they're pretty important. Let's do it next Monday. Turns out next Monday isn't all hands. So you're like, let's do it like next Thursday. And suddenly you're doing retrospectives for incidents that were like 2 or 3 weeks in the past. And I can tell you, we just went through all those human biases. Those retros are garbage. You might as well not even do them, right? Because you're just going to look at the data, and you're going to fill in the gaps with all the biases, and then you're going to get in together in a group, and you're going to fill in each other's gaps, and it's not going to be what actually happened. It's going to just be a biased narrative, right? Now, to that point, back to our thought experiment, I want to ask you some questions. What was the aircraft's call sign? What type of approach was the plane cleared for? To what runway? Or was it runways? What heading did the controller order the plane to fly before the emergency? And what radio frequency does the controller hand the plane off to? Now, here's the point that I want to make. And you may know the answer to some of these. And here's the interesting part is we could go check them with the tape, right? But this happened 25 minutes ago. And I told you I was going to ask you questions about it, right? So we should all know the answers to this, right? It should be super simple, right? So what's interesting about that is then to see like how much we forget even when it's something like that. And our incidents don't poke us on the shoulder and say, hey, there's going to be an incident in 5 minutes, so you should pay attention for the retrospective. They don't do that, right? One quick question. Who felt this was unfair because it was an aviation example? And they're not like planes, or they're not pilots or air traffic controllers? I get a lot that some people say, yeah, it's like, I don't know what happened, right? Why I wouldn't know to listen to this information, right? What's interesting about that is that we all know how planes work, right? We kind of get on the plane and then we, go to sleep and we wake up in a new place, right? So we all have an intrinsic sort of understanding of how the national airspace system works, right? But when you look at what actually happens day to day, there's a lot of messy stuff that goes on, right? And how many retrospectives do we go into and somebody says, oh, the database, I know how that works. We don't need the database team here, right? So a lot of times in these very complex interconnected systems, just want to make the point that sometimes we drag in our bias about, yeah, I more or less know how the code works if you're operations, or operations how if you're a developer, how operations works. But be careful, right? Because there's a lot of messy details. There's this idea in human factor system safety that's called work is imagined versus work is performed. Okay, I want to actually go through one last thing, and then it's lunchtime. So I want to talk about the Rasmussen triangle. What's interesting about the Rasmussen triangle is was a guy who studied 3 Mile Island. He's a safety scientist, and he came up with this idea. So on these edges of the triangle, we've got let's start over here, the boundary of economic failure. So that's the idea that if we go past that boundary, it'd be too expensive, and nobody would pay for it. So, you know, we wouldn't do it. Boundary of unacceptable workload, that's the idea that humans are lazy, and I don't mean that as an insult. We are evolutionary wired to get the most work done for the gram of glucose that we use in our brain. So it's just we try to do the most efficient thing. And then we also have the boundary of functionally acceptable performance or acceptable risk. That's the idea that once we pass that boundary, we have an accident or an incident, right? All right, so we've got that. Cheaper, better, faster. The business usually is always pushing us to do that. We're always pushing to do that. Where are we going together as a group, right? So you want to look at the discretionary space, and that's what's really important, is that organizations that are really good at this sort of understand when they understand where that boundary is, right? When they get to where failure is imminent. And you saw that with HROs, right? So we want to sort of explore that discretionary space so we know when we get close to it and we can step back instead of going over the edge. The last one here is relying on human error blame. Does anyone remember the S3 outage? Does anyone remember the S3 outage? Yeah. What was interesting is if you read that retrospective, they don't use the word human error once in the entire thing. Never, right? And if you also read that retro, what you find is they had an operational tool that didn't check its inputs, right? So it allowed an engineer to pull more servers out of rotation than they wanted, than they intended to. But when they found and did the retro, they found there are a bunch of other operational tools that Amazon has that don't check the bounds either. They don't have a -- force, I really want to take down S3 option to them, right? The service health dashboard's real dependencies. So the service health dashboard on Amazon didn't work. Why? Because it was on S3. Oops. The indexing subsystem insufficient partitioning due to growth. So in other words, it's partitioned, but US East had grown so much that they didn't have a procedure to repartition things, and over time these partitions got too huge. And I find this fascinating. The indexing subsystem had not been fully restarted in years. It'd been running for years, right? So the point here is if they had just called it human error and just fired the engineer, they would not have learned anything about how their system works or how they operate it, right? Okay, so the last closing points. So what now? So this is kind of fun and interesting, and I got to see planes do weird things. What now? The key to reframing failure is to stop thinking about incidents as events that went wrong and to think about them as your team's response to them, right? And a way to think of this is develop your incident immune system, right? The more you use it, the better it gets, just like our immune system. To make this practical, your operations in an infrastructure need to be retrospective ready, right? So we talked a little bit about what that means, but if you don't have that, this is going to be really difficult. And finally, the only thing we directly control in complex environments that we operate in is ourselves and our reactions. We sometimes think we control those systems directly, but it's actually, we're sort of reacting to them most of the time. Thanks. Quiz. There it is.
Very good. Thanks.